So we're gonna make here a video about Gen 5 tuning. I started Gen 5 tuning myself not that long ago. I shouldn't say that. I've done Gen 5 tuning, but I've not done a Gen 5 cam or something that actually requires you to do real work on a tune. So I started the other day, and we started with some videos from some popular people, and it did not get us anywhere. They were awful videos. So I figured, alright, got this car running pretty good, pretty much perfect. It's going to be coming back to run on the dyno to finalize it. But after that, we're like, it's time to make a lengthy video for people that actually show and explain what you need to do so you can understand what you're doing rather than just make random changes. So in this video, there is the predetermined assumption that you understand how VCM editor and VCM scanner work, because otherwise this video is going to be like an hour or two trying to explain everything. So one of the things you need to do is you need to have your scanner set up appropriately. Now I can make separate videos explaining this, but you're gonna want to have a graph set up for torque. A graph set up for torque. You're gonna want to have torque over here in your chart, and I believe somewhere in the channels, see engine torque. Okay. Now, the other thing you need is this little thing right here, this TM. This is Torque Management Advance. You absolutely need to know the Torque Management Advance, and you also have to have it here in the channels. You do not need to have it in the graphs. Yeah, if you want, you can make your own graph histogram for it. Though I don't know if it would be useful for most people. It's more or less something to reference. Okay. This is stuff that you're going to need for startup. Now, when you put a cam in a 5th gen engine, I put a pretty aggressive cam actually in this Corvette. I mean, we put a cam in with 15 degrees of overlap, and we were able to fire it right up, and after a couple revs and hold the pedal up a little bit, you're actually able to get the idle to stabilize and idle. So it's up to you. I prefer to start most motors and let them run for a minute and see what they're doing before I just start throwing tuning at them. But a person doesn't have to do that if they don't want to. So first thing when tuning almost anything is getting the idle set appropriately. So one of the things that you're going to see is you have I apologize, it's like 6 in the morning. Idle speed control reserve. Okay, this is the factory one on this Corvette. Okay, the idle speed control reserve, if you break down the name and think about it, it is like a it's a reserve. It is basically reserving a set amount of torque or air or spark for something to happen. When you put a choppy cam in, an engine actually is less efficient at idle. On a Gen 4, we increase the base airflow. We increase the timing to get it to run properly. Gen 5 is solely based on engine torque, so we can't do that anymore. So one of the first things I do is I copy 0.9 here, or 0.09, and I flash it to over here to 0.08. I don't know why it's not. Oh, my apologies. It's because we're on here. So we copy this, flash it over to here. Okay, so that way this table and this table match. And then you select the whole thing, and I times it by 0.8 until it gets to around 6 personally. A person can adjust this however they want. Typically, you get this to like this and you just leave it and you do not come back to it. External load. Idle external load. This table does not do as much as you would think it does based on the description. Idle external load models a zero pedal idle torque, and external loads to the engine uses an upper limit to idle torque requests. So in theory, you would think, oh, this is going to be the maximum allowed torque that it allows the engine to make at a specific RPM. This is what it looks like stock. So I prefer 7 to 750 for my idles. I do not like to go high. So I change 700 to 50. And from there, I select it down to, like roughly here. And then I interpolate between them. I think that's how you say that. Yes, interpolate between them. Okay. And then I select here to here. And I do the same thing. Now that is all you really need to do here. Limit offset, not really a big deal right here. This just adds a little bit of, allows more torque to go above the external load before everything freaks out. So you can typically leave that alone. I don't know why it's set at 60. I think I changed it and tried to change it back and forgot the exact number. Okay, so here comes the next big step. So you're going to want to start it up and you're going to want to log it. You're going to want to try and get the idle to stabilize. Now if you look here on this graph, the idle was, you started up and the idle chopping all over the place, moving up and down, and then all of a sudden it stabilized. Okay. Now, what you're going to want to watch is you want to watch your torque. Okay, so let's see, 772. Let's pick an RPM here. 775. Torque, 21 foot-pounds. Okay, decent. You don't need a lot of power to keep the engine running at idle. But what you're going to see here, torque management, 23 degrees. It is dropping from the spark tables in order to get it down, the torque down for it to idle properly. Notice how spark is only 3.5 degrees. Now with a choppy cam, sometimes it's up and down, up and down, up and down, up and down. Okay, so let's say you are getting this to jump. Let's say you're getting this to jump around, okay, and what we're looking at is cylinder air grams. We are looking at MAP. Okay. If this is jumping between 25 and 35, we need to make changes based on that. So let's go from here and let's go back into editor and I will explain. So virtual torque. Okay. First of all, change your increments to 50. Hit tab. Okay, what you see here on the left is air mass in milligrams. Okay, our air mass is in grams. Okay, so when you look at this, 0.29 is actually 290. Okay, so we're at 750 RPMs. That puts us right here. So let's scroll down to, we were in between 0 and 10 spark, so we can change this. So we can change spark to increments of 5. Okay, we were at, typically, let's say we're at 5. Okay, we're at 5. This right here, okay, this is exactly where we are. We are at 750 RPMs. We are roughly at 5 degrees of spark. And we are at 300 milligrams, give or take, of cylinder air mass coming in the engine. Well, if you notice here, there's only this right here says 63 foot-pounds. This right here says 21 foot-pounds. But we were pulling timing to get that. Okay, so the thing is this number here needs to be reduced. This number needs to be reduced decently. Okay, so everybody does this part a little bit different. Okay, I like to reduce it like that twice. Okay, and then I go from here to here, and I interpolate, and I go on this one. Not going to go as far because this is a high horsepower motor. I need the high power up in here. Okay, now extrapolate, whatever. So now let's move back down to here. You'll notice that even though it said like 30 or 40 when we did it, now it says 58. So the changes you make end up being significantly small. Even though we took off 20% twice, the change is only like 10 foot-pounds of torque here. You should only make small changes at a time in order to get what you need or what is desirable. So you do this to the air mass table first. Now, a lot of vehicles will idle in the 800 range. So typically, I go and I do these two. Now, a lot of times, it's between 250 and 300 milligrams. So then I do. Get off my screen. I do this whole section here, and then I interpolate. One of the things you need to keep in mind is that these are high horsepower engines. So what is going to fight you on here is you're going to have to go down here to 20 or 25 degrees of spark, and you're going to have to go up here into the upper range. So the part of the country I'm in, we're going to be right here, 600 to 700 cylinder air mass. This needs to be the actual foot-pounds that the car is going to make, or slightly above it. You cannot just max this out. So this area here is going to need a 20 to 40% increase. But when you do that and you extrapolate it, it's going to mess with these numbers here that you did change. So you are going to fight back and forth between allowing the car to make the maximum amount of power it should make and getting it to idle appropriately. So after you change the air mass, you need to change a couple of these other things. Okay, so if DOD is eliminated or the car doesn't have it, bottom four tables don't matter. So next we go to map. Okay, we need to do, let's see here. We are based on Spark, we are based on map KPA, and we are also based on foot-pounds. For those of you that don't know, if you put a dot 2 decimal places over, that will tell you what bar we're at. So my scanner is in bar right now, and the bar is 0.7. The bar is 0.7, meaning your map KPA is 70. Now if you notice, these two rows are significantly changed here. These are technically, they're about the same as the other one. So we need the same issue. We're right here, we're technically around 50. Look at that. We're at 60 foot-pounds of torque. Do the exact same thing as we did before. And extrapolate between them. Now, you can see we've done it a lot on this one based on the torque difference from here to here. So this is a hard one because these things do need to flow together properly. Try to get this to turn so you can see it. See right now is we're in this, we got this huge dip right here. the problem we have is that 70 bar or 0.7 bar is almost at the top of the map. It's difficult. So, you know, the thing that you're going to end up having to do, honestly, is, in my opinion, is essentially copy this. Okay, now this is when you're going to work on making horsepower and making torque. Copy this, go from here to here, and do that, because you need the power. Okay, and you're going to go down here to, and this is personal preference. If you don't want to do this, don't do this. But you'll notice here, most LS engines at wide open throttle in cars are going to be around 25 spark advance. Okay, so you need this power here to be a lot higher. See, this is only 160. The problem is you cannot make a change here without it affecting a change somewhere else. Okay, see how that's a, you know, 18 in every single one of these, all the way. Okay, so let's hit the extrapolate again. We are at 5 degrees advance, okay, and we're at 48 pounds, which is a lot better than where we were. You should never be at 80 to 100 here at idle, at least in the part of the country that I'm in. I feel that typically barometric pressure changes that, give or take, and maybe it would be higher, but either way, this is a good place to start. So here's your map table. I do feel that as you move forward, there's going to have to be some high horsepower numbers from here to here, this area here. You know, like this is going to be, you know, you're going to have to move this to like 400 or 500 and kind of shape this from here to here, because if you're idling here, when you get on it, you're going to come kind of like through this area here, right around here. So these numbers, you don't want these numbers limiting you by any means. One of the things that needs to be done next, and it does need to be done on this specific car, we just haven't done it yet, we actually turn the ethanol sensor off. So speaking of that, when you first start doing this, you may have to turn the ethanol sensor off so it doesn't mess with anything. E85 air mass, if you're going to be running on ethanol, you need to do both these ethanol tables. Okay, so every time you make a change, every time you do this and then you log your idle, you have to keep coming back and you have to keep repeating this. Okay, you have to repeat this step, but this is not the only step. So the virtual torque is the main thing, okay? But you have multiple tables that you have to change. The next one is driver demand, okay? So we turn off torque shaping and we go to this area here, okay? This is what it used to look like. This is what it looks like now. Now you need to pay attention to your pedal, okay? TPS, 24.5 degrees, okay? Now, let's see if this changes. Okay, so we're at 23, 24. Okay, so what I typically do is I grab this whole thing and we make a reduction. Okay, this torque in this area here needs to be as close as possible to the actual torque the engine is physically trying to make or trying to keep you at while idling. You need to change the virtual torque air mass, the virtual torque map, and then you have to change the driver demand. And you have to do this each time before you log. And every time you make a change, it is going to start idling better and better and better. You know, but like I said, the cylinder mass, the cylinder air mass might bump up around. When I first started this car, it would bump from 0.13, so 130 milligrams, all the way up to 0.57, so 570 milligrams. So I had to make bigger changes at first until it started dialing down and becoming close. This log is not perfect. This is still 20 degrees of torque management timing. This, we want to be at like 5 degrees or less. We want the car not to fight the motor. We want the motor to be able to do its own work and not have the car fight it. When the car first was started, this is what it did. When I first started working with it, it was this section here. Now notice, 98 foot-pounds of torque, negative 20, negative 13, 187. This was going all the way up to 300 foot-pounds of torque, trying to stay running. Basically, the idle would drop, the torque would skyrocket, the idle would go up, and it would keep doing that, up and down, up and down, up and down. Now, as you can see here, this is a graph that's like 2 minutes long of it idling, and it idles fairly smooth for a big cam. And like I said, this is like 13, 14 degrees of overlap on this cam, and it sounds amazing. This is how you dial in the idle. You have to do this. This is the only way for it to work appropriately. One of the other things that I'm going to mention is that at this time, you should shut off speed density or the mass airflow. I prefer to shut off speed density first and work with the mass airflow, then shut off MAF and work for speed density. Everybody does this different. So again, we have other videos explaining that, but I'll make a quick, I'll just show it quick, okay? So airflow, speed density, probably not the right spot here, dynamic, okay. So when you want to remove speed density from the equation of trying to start dialing in your vehicle, you move the high RPM disable to 4,000. Above this RPM, use filter air mass for air mass prediction calculations. This means above 4,000, it's going to use speed density and mass airflow. Now, if you wanted to use just speed density, you set this to 0, you go to engine diagnostics, and you set MAF frequency failure to 14,000. And it will automatically set a P0102, and it will put you in speed density mode. Now, there is a lot to take in here for most people on this. So if you have questions, please talk to me. One of the things that I do is we take this throttle area percent max from 200 and we drop it down to 100. This particular vehicle, we turned off the variable camshaft because it got a full limiter on the camshaft. Fuel power enrichment. Same thing on most vehicles. I do 0, 0, 0, 250, enable pedal, 40%, 30%, 20. EQ ratio was running a little rich factory there, so we knocked that down. Turn off temperature control, move the cutout wherever we want it. Make sure you got DOD disabled. You know, flex fuel, we have the torque, or we have the flex fuel disabled at this moment. One of the things that people need to keep in mind is this cannot be done like a normal Gen 4. If you go in here and you just put and change this right here, because this is what's normal for most people, they go, okay, 18 degrees, they start off at 18 degrees, interpolate this way, interpolate this way, and now you have a minimal idle for your minimal spark for your idle. Don't do it. I've heard it's crappy, so we've tried it. We've tried it to see what it would do. It absolutely does not do you any good. It actually fights it worse than if you just leave things how they are. So forget the Gen 4 stuff on a lot of this stuff, because it's not going to help you at all. Let's see what else we had here. see if we made. So these driver demand tables, I actually make all the tables the same driver demand. I'm just trying to think if there's anything else that in particular that needs to be said. I don't think we changed anything with the fuel. I think we made the fuel stuff all stock. So let's go back here. Now, you're going to want to have fuel rail pressure as well, just so you can check the references on it. You're going to notice that your injector flow rate changes based on fuel pressure, things like that. You want to have as much stuff in here as physically possible for you to reference, whether it's engine misfires, engine knock, fuel trims, fuel pressure. You know, we have, I mean, 399 kPa is like 40 psi or something like that, or 45 psi. I think you could. No, 58 psi. My bad. I'm an idiot. So I leave this at kPa because that's what the car is referencing. You know, I use air-fuel ratio on this specific because whatever, it doesn't matter. People want to be crybabies and use EQ ratio or whatever. And, you know, to be completely honest, it doesn't matter. For most of us, air-fuel ratio is faster in our brains to comprehend than the metric version of it. Barometric pressure, blah, 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 ambient air temperature, which this is super off. It was not 150 out, but more than likely the hood was closed, and it was over 100 outside. The hood being closed is why you got the 163 intake air temperatures here. Keep in mind when you're trying to get the idle stuff dialed in, you probably should make sure the hood's open and get the car in the shade or something, so that way your numbers aren't skewed. I don't know if I should do a quick go over of the virtual torque again, or explain it a little bit better. So the virtual torque system is the vehicle's way of controlling itself. It's actually a very smart system because it's using engine torque to control everything. Everything is 100% based on engine torque. You change this table, it will change all kinds of things in this vehicle. There's no more base airflow. None of that stuff no longer exists. Almost everything you do is right here. It is like if you were to take virtual torque and virtual VE, that would be like the equivalent of Dodge's neural network, except for the Chevy stuff is significantly easy to mess with. If you have any questions, feel free to message me, but this will cover the basics. This will get you running good. But like I said, don't forget that you need to add power up here based on what the car is going to make. And it doesn't hurt to run it on an engine or run it on a dyno. Dyno it, make changes, dyno it again, make changes, because if you go too far, you actually end up hurting yourself. This table should somewhat match what the engine's actually going to do.